So good morning once again. This is just a quick review of what we have discussed so far. We learned about the concept of the time value of money. We said that when you evaluate capital budgeting projects, what you do first is to compute for the the cash flows. Okay. Notice that we don't use here, this one are cash flows per time. Okay, these are not income accounts. These are not income amounts. What is used is cash flows, because the purpose for that is that when you evaluate projects, you're not actually looking at the present values of your net income. When you acquire funds for the project, you acquire cash. Okay, so since you're acquiring cash, when you assess a project, it should be cash based also. The basis should be cash. But how do you come up with cash? Well, you first come up with a projected income statement. Say you have your revenues, expenses, operating expenses, interest if there's any, and then tax. So you arrive at net income after tax. So just a quick review from a financial perspective: your revenues, and then you subtract your cost of goods sold or cost of sales, and then so you get your here you get your gross profit, right? Just so we know how we arrive at the gross profit, and then we subtract the OPEX. Okay, you have your OPEX, so you have your EBIT, earnings before interest and taxes. Then you subtract your interest to come up with earnings after tax. Oops. So this is your earnings after tax. Sorry, earnings before tax, sorry. So less interest, then less tax. So you have your net income after tax. Okay. So when you have this class, so this is on a per period basis, let's say year one, year zero, year one, etc. We don't use this one. We don't use this figure in analyzing your capital budgeting project. Rather, here we add back non-cash items. Okay? You add your non-cash items that you deducted here from your income statement so that you have your cash flow here. Okay? All right. So this is what we pick up and put here in our capital budgeting. Okay. So you go down the line of the income statement and arrive at the net income after tax. You have to adjust the net income after tax. So you add non-cash items that were subtracted, or you subtract non-cash items that were added. So it's just the reverse. However, you convert your net income after tax to cash flows. And then this is the one that we pick up and put here. Okay. All right. Let me pause for a while and ask for your confirmation if that's clear. You need any clarification about that? Any questions about that? Okay, good. Thank you. All right. So please bear that in mind. Okay. We don't use the net income after tax because net income after tax is not cash basis. Okay. So when we evaluate our capital budgeting project, you notice that the net present value is the sum of the cash flows here. Specifically, it's not profit, it's not net income, it's cash flows. And then this one, you divide it by 1 plus k to the t. This is now your present value, right? If you remember, your present value is equal to your future value divided by your times your discount rate, or times 1 over 1 plus k raised to the t. So this is your present value, and then you subtract the initial investment, which is your which is a present value cash outflow also. So you have here our net present value. And we said that the decision rule is that if your net present value is positive, then the project is feasible. It's okay. And if you're comparing class, if you're comparing net present values, generally, the higher, the better. Okay. However, when the initial investment is different, for example, for this one, okay, for project Y, the initial investment is 1.2 million. For project Z, it's 1.8 million. So there might be a bias here because technically, suppose this one will be let's say, it will require the purchase of a much more advanced equipment compared to this one. So chances are the much more advanced equipment might generate bigger cash flows. And having bigger cash flows might mean a bigger, of course, bigger net present value. So in instances like this, when the initial investments are different, let's say this is more expensive, okay, what do we do? In comes your profitability index, okay, because your profitability index computes for your net present value per peso of investment, okay, because you're dividing it by the initial investment. Okay, so here you can see that even if the initial investment for project Z was bigger, okay, yet the profitability index is higher. Okay, so still, with respect to the profitability index, the project Z is better. Okay, at least you have a a comparison which is, let's say, equivalent, because this means you generate 1.133 cash flows, present value of cash flows per peso of investment. This one, 1.136 present value of cash flows per 1 peso of investment. Okay, is that clear, class? The concept of net present value and profitability index. That clear? That we're able to compare equitably, quote unquote. That's good. All right. That's good. Okay. All right. Thank you. Okay. Now we also learned about IRR, internal rate of return. So there are two main ways of assessing a capital budgeting project. By the way, when I say capital budgeting, based on what you learned in your financial management, this is a type of expenditure that will benefit long periods of time. Okay, usually more than 1 year, 2 years, 3 years, etc. As compared to an OPEX. Okay, OPEX is operating expenditure, a type of expenditure which will only benefit one operating year, as compared to CAPEX, which will benefit more than 1 year. Okay, that's why here you have, okay, a computation of using 5 years, 5-year period. Okay, so you can either use NPV or IRR. Okay, IRR tells us how much return that project has, and you compare it with your weighted average cost of capital. The decision rule is that if your IRR is greater than your weighted average cost of capital, then the project is okay. Now also, incidentally, your IRR is that rate of return where your net present value is equal to 0. Okay, so we computed this last time. Okay, we computed the net present value using the rate as your IRR, and we get 0 NPV. Okay, now we also said that when there's a conflict between your net present value and IRR, you choose the NPV. Okay, you choose the NPV because when you compute for the IRR, there are certain assumptions that you that you use. Okay, and that certain assumptions makes that the computation of IRR a bit not as solidly sound as compared to NPV. That's why there's another type of IRR called the MIRR, modified IRR. Okay, and the modified RRR, okay, makes a certain assumption that is in line with NPV. So the MIRR will always have the same result as your NPV. Okay, just like in this case, we computed for the IRR. The IRR of project Y is larger here, 18.23 as compared to project Z. So this conflicts with our NPV because based on NPV and even profitability index, project Z is better. In terms of IRR, project Y is better. All right. So this is an example where the result of your NPV and IRR conflict with each other. And as we said, in all cases, always follow NPV. Okay. Always follow NPV. So here we computed using another type of IRR, which is the modified. Okay. The modified IRR. And we can see here that the net present value is higher for project Z if we use the modified internal rate of return. Okay, so any questions about these four so far, class? NPV, profitability index, IRR, and MIRR. Any questions about that? Okay, good. Okay, good. Thank you. We will have to schedule class one. So we'll have one or two, maybe one, just one or two. Let's see, one face-to-face exams, and then the others will be cases. Okay, so we'll just decide when. No, we'll have to find a common time. Okay, we can take it if there's no room. We can take it dun sa ano lang, kahit dun lang tayo sa faculty, dun sa faculty area ng Department of Financial Management. Of course, you'll have to bring your laptops. Okay, so we also discussed another way to determine if a project is feasible or not, okay, using the payback period. Okay, the payback period is a number of periods, in this case years, where the initial investment is recovered. Okay, so you just take the cumulative cash flows, we did this last time, and you determine in which point where the cumulative cash flows becomes positive. When it's positive, it means that you have fully recovered your initial investment. And in this case, we computed that it's 2.94. Okay, we were assuming that we took the ratio here of what was needed divided by what is to be expected the following year. And we're assuming that the cash flows is received uniformly throughout the period. So it's 2.94. However, there's a, okay, maybe we should do this, class. Okay, you can copy the formula here. Control C, Control V. Okay, it's, yeah, just getting sum. Okay, so for this one, it's how many years? It's 3. Okay, 3 plus, we need to recover at this period 410. So I'm going to get the positive value of this and then prorate it with the cash flow that we're going to receive the following year. Yeah. Okay, 3.58. Okay, so it will take us around 3.6 years to recover this initial investment. And what's the decision rule, class? Well, it depends. A company might have a policy that the payback period for a project should be, let's say, not to exceed half the life of the project. So if it's 5 years, the half life is 2.5. Okay, then if they're going to be strict about that, then they will say that this will fail. Both of this will fail. Or if it's let's say, it depends, 80% of the life of the project, so it's 5 years times 80% of that 4 years, and both of this will be okay. So the payback period just allows us to compute for the number of years it will take us to recover the initial investment. However, the weakness of this payback period is that it adds your cash flows. on different periods, which we say violates the time value of money. So a better method is a discounted payback period, where what you consider are the present values here. Okay, so we got the present values, and that's where we get our discounted payback period. The same thing here, class. Okay, so I'll give you a few seconds, class. What is the discounted payback period for project Z? Okay, so please compute. Okay, we have an answer. 3.6. Okay. How about the others? Did you get 3.6? What about the others? What is the discounted payback period for project Z? Okay, for Arliana, 4.5, 4.3, 3.6. Okay, so we're getting different answers. Okay, how about the others, class, please? Okay, Johan. So Johan and Nix got 3.6. Aliana got 4.3. Okay, Sami got 4.5. How about the others? Okay, Jashan and all right. So some of you have the same answers, some of you have different answers. Let's let's validate them. Let's validate the answer. So you first get the present value, right? And the present value of this, we can use the negative PV function. And your rate is we're using the WACC, right? The WACC. Oops. Maybe I'll just use this one plus. Hmm, where's that? This one? Yeah. Okay. So that it will not have to define the location. And per is this one, 0, comma. PMT, no PMT, comma. Future value is this one. Okay. Type ignore. Control enter. Okay. Expected 1.8 also. There. So these are your present values. So we can now accumulate this. Sum of this one. Okay. Colon. And then I'm going to fix first one. Just fix the fix the column B. Okay. Control enter. So copy this to the right. Okay. So it's around 4 years, class. Okay, it's around 4 years, after 4 years. Okay, so this will be equal to 4 plus, okay. How much more do we need? Do we need to recover this amount? Negative. This one divided by the cash flow, the present value cash flow we expect is this one. Close. No need to close this. So it's 4.5, class. 4.5 years. So some of you got it. Okay, good. Some of you, I think, use this one. Okay. So you have to use this one because two. Yeah, I'm sorry. I'm sorry here, class. I made a mistake here. We're adding here. Apologies, class, not this one, but this one. Okay. Kindly correct, class. So this is 4.2 and this is 4.5. Yeah. My mistake here is that I used this one. Okay. I should have been using this one. You're adding the present values of the cash flows. And you can see here, what are we adding? Okay, we're adding this one. Okay. All right. So 4.2 here and 4.5. Okay, I stand corrected. Please correct your Excel worksheet. Okay, so let's go here, class. Let's go here. Okay. Now you have here your initial investment. So these are in millions. These are also your cash flows. Okay. Now the question is, what will be our, okay, what will be the best among these different projects? Okay, I'll first give you 1 minute, thus. The required return, the WACC is similar to for all, 12%. Although we don't need to, okay, actually don't need to put everything here. Okay, just for the practice of using just one. Okay, so I want you to create one formula here and tell me, class, please tell me in the chat box, which is the best project, A, B, C, or D? I'll give you a minute. Please do that. Just one formula here, class. The challenge is just create one formula here and then copy to the right. Okay, let's get the net present value, class. We can use one formula here is equal to NPV. Okay, and you know how to use the NPV. The rate is, of course, 12% here, and then we will fix this. Let's fix just the column, okay, comma. The values, class, if you recall, we have to get the starting with year 1. I'm going to highlight this, but I'm going to highlight up to year 8 because the others are up to year 8. Okay, you can do this, class, because for the others without up to year 8, these are all equal to 0. So the present values of all these zeros will be 0. So it will not change the solution. Okay, so I copy this, not yet, no? And then, so those are the future cash flows, and then we add plus the initial investment here. Okay, so control enter. 60,000 for project A, 95,000 for project B, 98,000 for project Z, and project D has 126,000. Okay, of course, again, there will be a bias for project D because it has 8 years of project life. Okay, so how do you now compare projects that have that have unequal lives? So this is 6 years, this is 4 years, 5 years, and 8 years. The long cut is actually this one. It's actually like coming up with a, okay, let me just illustrate that. It's just getting the least common denominator of this. Okay, for example, Control C. Okay, let me just illustrate that. So this is for project A. Okay, and then when it ends, it's like as if you're going to repeat the project. So if you repeat this, Control C, you go here, there, okay, and then you repeat the project again. Okay, so this is how many years is this? 6. If you get the LCD class, 4, this is 5. Okay, sorry for the little a little math. No? So 8, and then you have let's have first 6, and then 4, and then 5, and then 6, 4, 5, and then 8. Okay, if you recall in your algebra, what you do is get the factors for this 3 and 2. Okay, this is 2 and 2. This is 5 and 1. And this is 2 and 2 and 2, right? So how do we get the least common denominator? So 2 used once here, used twice here. So what will prevail is this 2 times 2 times 2. 2 is used 3 times. So what else? 3 is used once here. It's not used here. So it's 3 is used only once. Okay. And then lastly, 5. 5 is not used in the others, but it's used 1 here. So that will prevail. Okay. So it's like 2 times 2 times 2 times 3 times 5. Okay. So that's actually 120. So if you get the equivalent equivalent years of this, so it's as if you're getting 120. Okay, 120. So okay, this is just 6, 6, and 6. So this is just 18. So you have to repeat this until you get 120. Okay, and you keep on adding. You keep on adding. For example, this one, Control C. At the end of this, you'll have another one, Control V. Okay, and then another one, Control V, and then another one, Control V. Okay, and another one, Control V, until you reach 120. So let me just illustrate that. Okay, so I'll put this. This is 0. Okay, 1, 2, 3. Okay, then I'll just choose sequence is equal to sequence. How many rows? I need 120 rows. Okay, and I'll start with 0. Step is 1. Control Enter. Spill. Okay, what happened here? Wait. Okay, let me there. Okay, 119. So it should be 120. Okay, I have to repeat this. Sequence be 121 because I started with 0. All right. So I keep on repeating this. Control C. At the last year, I start again, Control V, and then at Control V again, and then Control V. Okay. Sorry to be illustrating this, but Control V, Control V, Control V, Control V, Control V, Control V, 102, Control V, okay, Control V. There you go. It should be up to 120. Okay. And then, okay, what do I do, class? I add the cash flows. So just to illustrate, this one I should have placed here. Okay. My mistake. I should have placed this one here. Okay. This one I should have placed here. Okay, what am I doing, class? I'm creating a series of cash flows based on this project. Okay, anyway. Okay, let me just finish this and explain, class. Just to illustrate what will be happening in this process, and it's quite a tedious process, but thank goodness there's a shortcut for this. Okay, I just want to illustrate this. So is equal to, we got the sum. Okay, and then copy down there. All right. So this one, class, this one is the equivalent cash flow of this project repeated. Okay, repeated how many times? 120 divided by 6. Repeated 20 times. Repeated 20 times. So why 120, class? Because that's the least common denominator of this three numbers, 6, 4, 5, 8. I'm going to repeat that for this project. So you can imagine this will take 30 process like that. This one will take divide by 5, 120 divide by 5. So that's 224. And this one also, okay? So you'll keep on repeating each project so that it reaches 120. Why 120? To make the number of periods equivalent. So just to explain this is your initial cash flow. Then you're going at the end of the project here, you're going to repeat the process. So it's as if you're going to have that same project. So that's why I created this. Okay. I'm adding this, class, because it's as if you're replicating or repeating the project. And again, at the end of this, another same cash flow, okay, another same cash flow, etc. Okay, and you're adding them. Okay, so you can now get the net present value of this. And you can repeat the process for this project, for the one with 4 years, same thing. The one with 5 years, and all should have 120 years. And that's possible because that's their least common denominator. Okay, so you don't have to do that, class, but that's how it's done. Okay, manually. Okay, however, the good thing here, so if we do that, by the way, if you do that, then since they're all now in the same years, 120, then computing for the net present value, let's say here, class, is equal to NPV. Okay, the rate is 12%, right? 12%, comma. The cash flows are, what are the cash flows? All these future cash flows here. What happened? Okay. And then comma. I'm sorry. I'll close this. And then plus the initial cash flow. This one. R7 by R7. S7. S7. Okay. Control Enter. And you get this Okay, 123,01019.21. Okay, so this is the equivalent net present value of this project taken 120 years. So you keep on repeating the project for 120 years. And then you do the same for project B, also 120 years, and project C and project D. And then you get their net present values. Now, question class, will you now be able to compare the net present values if you do that, if you replicate the project for 120 years for A, B, C, D? Yes or no, class? Okay, thank you, Sami. How about the others, please? Okay, yes, yes. Yeah, you're correct. You can now compare because all of them have the same have the same time frame. Okay. Okay. The good thing is you don't have to do that. Yes. So what we're going to do is we're going to what we call annualize the net present value. We're going to compare it on an annual basis. Plus, okay, so there's a process of doing that. The process of doing that is, okay, how do you annualize? Okay, let me illustrate that. Draw. Okay. Is my digital pen working already? Not yet. I don't know what's happening with my digital pen. It's not working. Okay, anyway, I'll use the mouse. Okay, so we have here, okay, for this project A, okay, we'll have to compute the present value interest factor of an annuity of 1. Okay, what's that, class? Present value interest factor of an annuity of 1. What does that mean, class? So you have an annuity for project A, it's 6 years. Okay, annuity of 1. 1, second, 3, sorry for my drawing, 4th year, 5th year, and 6th year. 6 years, and then you have an annuity of 1. So, what do you call class? Annuity, uniform cash flows, there. And these are all 1. Okay, all 1. 1, 1, 1, 1, 1, 1. So, how do you get the present value, class? How much is the present value of an annuity of 6 years? Okay, so that's very easy. That's very easy, class. So let's do that. Is equal to, you have your PV. Okay, PV, our rate is 12%, and then I fix this F4 there, comma. What's our N per? Our N per, class, is what's our N per here? What's our N per here, class? It's 6, right? For this one, it's 4. For this one, it's 5. For this one, it's 8. Now, I want just one formula, class. How do I now make this 6? Then I copy this, it will become 4. Then I copy this, it will become 5. Then I copy this, it becomes 8. Okay, maybe I'll let you try that, class. And then the PMT should be 1. Okay, all right, I'll give you a few seconds, class. Try that. And as I said, what will matter here is the number of years, the N per. So how can you now? Can you click this one, 6? Okay. If you click this one and fix this, then this one will also be 6. Okay, and that will make it wrong, class, because the period is very important. The present value of an annuity will depend on how long that annuity is. Okay. Okay. So it's 6 for project A, but it's 5 for project 4 for project B. Okay, I'll pause for a while. I'll stop recording. To get the present value interest factor of an annuity of 1, okay, call it PVIFA 1. Okay, so for project A that has a period of 6 years, PV, the rate is 12%. Then we fix this, fix the column so that when we copy to the right, the column will not move. N per here is 6, right? Then PMT, it's an annuity of 1. Okay, class, and then comma, comma, it's at the end of the period. It's an annuity ordinary there. Okay, if we do this class, the present value of that is 4.11. However, of course, we cannot copy this to the right. Okay. Hello, sorry, class, sorry for the interruption. Okay, so we can't do this, right? So what we have to do is, we have to do something with this one. So definitely we'll have to change this, and it's a simple function, okay, counting, count A. So what's count A, class? Counts the number of cells in a range that are not empty, okay? So what we do is, we count this, not empty. So I'll start here. I don't include 0, class, here, and then I go here, class, so that I can copy the formula, okay? I can copy the formula to the right. Count A, and then if I go here, it will count those that are not empty, 1, 2, 3, 4. And then here, 5, and then here will be 8. Okay, so count A, class. Count A. Okay, control enter. And then if we copy this to the right, okay, there you go, class. See. So here, this one. What's this, class? Okay, wait. So this class is, see, you can see the answer here, 4, okay? And this is of course 5, etc. Okay, let me pause for a while and ask for, if you got it, class, any feedback, or if you understood the formula. Okay, how about the others? No questions? Okay. Sorry, class. All right, good, good. So now, class, since we have computed for the present value interest factor of an annuity of 1, we can now annualize this. We just divide this 60 by 4.11 there. So this is now your annualized net present value. Okay. And based on the annualized net present value, okay, this is our best option since it has the highest annualized net present value. Okay. All right. I'll give you a few seconds to work on your worksheet. All right. Any questions? Any questions, class? Okay, good. May I ask you, class, if you discussed this in your financial management? Were you given scenarios like this where the projects were not of the same periods in your financial management class? Did you discuss this? Okay. Okay. How about the others? Okay. All right. Good. That's no problem with that. Now you know, class, if you have unequal lives, you just can't get the net present value. Okay, because it will bias the one with a longer project. I'm not saying that if it has longer life, then it will always be higher. Of course, it will depend on the cash flow. However, even if you have situations like this, even if they're just two projects, okay, the one that we were doing a while ago, this one, we didn't have problem with unequal lives because they're both 5 years. For this one, okay, you have four projects with different periods, then that's why we have to get the annualized, call this the annualized net present value. All right. So next class, let's go to multiple IRRs. Okay, sorry about that. Let's delete this. Okay. Now take a look at this class. You have this unusual project, okay? Unusual project where you have this one is understood. For the first year, for the 0th year, you're expected to have an outflow. Okay. But this one at the end of the period, at the end of the project, or even intervening, plus maybe on the 3rd year, not necessarily on the last, you have another negative outflow. You have an outflow here. Okay. So okay, what will happen now? You have you'll have in this case, class, you might have two different IRRs. Okay, so let's do that. So it's equal to IRR. Okay, IRR, and you know, class, that here it's straightforward. Okay, so the IRR is 3.91. Why don't I increase? Okay, 3.91. Okay. Now, when you have intervening negative cash flows, there's a possibility that there's another IRR. And you can do this by using IRR and then the values and then putting in something in the guess. So let's say guess 10%. Let's say just any guess, class. So it's still the same. Okay, so we haven't hit the right guess. Okay, maybe increase this, let's say 20%, 20%. All right, there you go. So we were able to find another IRR. Okay, and usually there are two, 30.28. It's different from 3.91. Okay, so it's different from 3.91. All right, so let's now plot, okay, let's now insert the WACC from 0% to 40% increments of 2%. Okay, so how do we do that? How do we do this? Okay, if you recall class, I think you can use the sequence function. Okay, maybe let's do that. So is equal to sequence. So how many rows? Okay, we have to count the rows. No? So let's say 20 rows, comma, comma. You start with 0, okay? And then step is increment of 2%. There, control enter. Okay, so there you go. So we should have written here 21. So until 40%. Let's make it percentage. Okay, let me pause for a while, class. Are you able to follow? Okay, good, thank you. Okay, so we use the sequence function, class. All right. Now we will have to insert this in our weighted average cost of capital. Now let's see. I'm not sure if we can change this. I'm going to drag this down. Okay, it doesn't want. Okay, ayaw niya class, no? Ayaw niya kasi array to eh. So this is an array. So what we do is we'll copy this control, okay? We'll copy this class. Control C, okay? And then paste values. So that way, what happened, class? Nawala na yung sequence function. Okay. Notice it's no longer class the sequence function. Now, what was my purpose for that? I want to insert 3.91 and 30.28. So here, it's between 2% and 4%. I'm going to put, okay. So this is equal to this one, okay, 3.91%. I'm inserting in my WACC between 2.4 and 3.91. And then I'm inserting here between 30 and 32 is 30.28. It's equal to 30.28 there. Okay. The sequence function is still there. Okay. Again, class control Z, control Z, control Z, control Z, control Z. Okay, I went back here, class. Okay, nawala na yung sequence function ko, no? Control Z. Here. So if I highlight all the cells, class, you notice that this is the formula sequence. So I want to remove the sequence because I want to insert 3.91. We can't insert 3.91% class if there's this sequence. Excel will not allow that. So what we do, highlight your sequence, all the cells, and that will show here. Okay, and then Control C, copy it, Control C, and then right click here, paste special values. Okay, so it will copy the cells and paste it as a value there. And notice now that the sequence function is no longer there. Okay, these are still highlighted, and the sequence function has disappeared because I have copied the cells and pasted it as values. So we can now, let me put this as percentage. We can now insert here. Okay, I can drag this down. And then this is equal to this. And then for the other one, 30.28. This is equal to there. So it's between 30 and 32. This is between 2% and 4%. Okay, class? All right, so we can now compute for the net present value. Okay, let's see if we can copy everything, you can highlight everything here, and then type is equal to NPV. The rate is, what's the rate? Did you write it? Okay, sorry. Let's put the rate here. Yeah, it's here, 10%. So let's just put this here. No, sorry. My mistake, class. Okay. The rate is this one, of course. Highlight is equal to NPV. The rate is this one, okay, comma. What are the values, class? These are the values. Then we have to fix that. We can fix just the rows. We're going to copy it down, comma, okay, and then plus the initial investment, this one, then also fix the row there. And then Control Shift Enter, let's see. Oops, wrong. That didn't work, sorry. Okay, so let's do it one by one. NPV, this is the rate, comma. The values are this one. Don't include the first one. And then fix the row. Plus this one. There. And Control Enter. Okay, it's a problem here. Okay, Control Enter. What's the message here? Double click. Can change the part. Okay. Yeah, sorry. I still have the formula here. Okay. I still have the formula, the array formula. So I need to delete this. Delete. Okay. Okay, so no more array formula class. Because a while ago, I highlighted all the rows and then placed a formula there. So I was putting a formula inside an array and I haven't deleted that. So I deleted it now. So NPV, the rate is 0%, comma. The values, remember class, these are net present values. So highlight this and then fix the row there. And then plus the first cash flow, fix the row. Control Enter. So there you go. That's the net present value. Double click. Okay. So these are the net present values given the different the different the different weight costs of capital or discount rate. I'll put this in box like this. Okay, let me pause for a while and ask you if you're able to follow, class. We're getting the net present values based on different average cost of capitals. What's the point of the guess? Okay, thank you, Nix. A good question. Nix, kindly share your question, your answer to your question to the others, please. Okay, Nix has a very important question here. What's the point of the guess in the IRR formula? Okay, now we said that usually if you have a cash flow, the normal cash flow is that you don't have a negative an outflow in the succeeding periods. Okay, what, for example, in our cash flows here, class, the outflow is only at year zero. Okay, the succeeding periods have positive cash flows. Same thing here. Initial investment negative, and then this one positive. Now there are instances when you have an intervening cash flow that's negative, like this one. At the end of the period here, it's a negative cash flow. So when that happens, it's possible that you'll have two sets of IRRs. Okay, usually it's two. So the first IRR we were able to get just using the regular formula. Now, how do we get this possible second IRR? We have to make use of the guess function, because if you don't, then we will not have that. We will not have that price. You won't be able to find that there. It's still 3.91. So what we did was so we were coming from the fact that there's a negative there's a cash outflow after year zero. In fact, here it's on year 5. So in order to get that possible IRR, you have to use the guess. Okay, we started with 10%. Okay, so that's a guess IRR, but you're not getting it. It's 3.91. You can experiment. Is it 12%? Will we be able to get that 12%? No. So I increase it a bit, 20%, 20%. Okay, there you go. So I used a higher guess. Okay, in fact, class, let's say if I use, let's say 40%, okay, it's still 30.28. And if I use a much higher one, it will still be 30.28, which tells us that these are the two IRRs. Okay, next, did that answer your question? How did it assume po? Hindi, nag-compute siya. Excel computed for that 30.28. Okay? And as I said, guess is only 20, guess, it's just a guess. Okay? It will draw out, it will draw out the other IRR. Okay? In fact, I showed you that if I use 40%, here, let me use 100% as a guess. So what will be now your IRR? Still 30.28. Okay? Nick, did that answer your question, please? Okay, thank you. Now, let's show, class. Let's show. And notice that at the IRR 3.9 to 1, the NPV is 0. Take a look at this, class. 3.9 to 1, the NPV is 0 here. Okay, if you recall, that should be the case, class. How about in the other IRR here, class? 30.28, and the NPV is 0. So which means if we plot this, it will cross the x-axis 2 times. Okay, so let's plot this, class. Control Shift down arrow. Okay, and then insert. Okay, so let's use a line chart. Okay, this one there. Okay, take a look at this class. You notice on the x-axis, class, you have your IRR. Okay, on the y-axis, you have your NPV. Okay, so notice that this is 3.91 and this is 30.28. These are IRRs where your net present value are all equal to 0. Okay, so what can we deduce out of this one? The range from 3.91 to 30.28 is the range where your net present values are positive. Okay, so this is your acceptance region range. So if your net present, if your IRR is 10%, then the project is okay. But the best, okay, the highest is at this point. So this is around 14%, okay, 14%, and it's 8.74. We can, of course, make this more granular. Let's say making it 1% or increments of 0.5% to really get this value. So it is at this point around 14% where you have the highest highest NPV. Okay, now let's compare this, okay, by way of comparison last year. Let's go back to this one. Okay, for this one class. For project Z, let's also create, okay, let's copy this class. Control C, and we go here. Let's go here, crossover here, multiple IRRs. And then let's do it here, class. I'm going to, okay, copy it this way. All right. And let's, in the same manner, let's have our WACC and our NPV. Okay. So this is year 0, 1, 2. So just comparing, class, IRR here is equal to IRR. So it's 17%, right? Okay. And then if you try again, class, it's equal to IRR. And then make a guess, let's say guess of, let's say 100%. That's very high, class. Okay. Same thing. It means that there's no other IRR. You only have one IRR in this cash flow. Okay. So let's again make use of this 0%. Okay. We can, okay, anyway, it's passed anyway. And copy up to 40% here. And then let's insert this one, 17%. I'm going to insert it here. Okay. And then this is equal to 17.39. Okay. So unlike the one with a negative cash flow after the initial investment, this one does not have a negative cash flow. And you only have one IRR. So let's compute for the NPV. Say this is also 12%. I'm sorry. No. So our NPV is equal to NPV. My bad. This is the rate, comma. Okay, the values are, we start with year 1. Okay. And then we fix this. Close parenthesis plus the initial investment, F4 there. So that's our formula class for this cash flow. Okay, Control Enter. And then I copy down. There you go. And you can see at 17.39%, the net present value is 0. And if we plot this, I once again highlight this, and then insert. Same thing, this one, right. You can now see the difference. Okay. Okay. So you can see here the difference in the NPV profile. This cash flow class, notice that there's only one IRR here. This is the IRR. It's around 17 point something percent. And you can validate that because at that level, your NPV is equal to 0. And this will continue going down. Okay. If you let's say you increase this, and then you copy the NPV. Okay. It will keep on becoming more negative and more negative and more negative. On the other hand, for our other cash flow with a negative, okay, you can see this one, class. There was a point when the NPV kept on increasing, and then when it reached the maximum, it went down, reached again the IRR, okay, and then downward already here. There will be no another rebound. Okay, but there are two IRRs here. And this is all because you have your cash flows that are negative after the initial investment. Okay, let me pause for a while and allow you to update your notes. Okay, let's put this up here. Okay, I can replot this and include this one. Okay, are there any questions, class? Any clarifications? Okay, good. Waiting for the feedback of others. Good, thank you. Yes, very good, thank you. Okay. Who has some? Jishan, how are you? Are you able to follow? Jishan? Okay, good. All right. Okay, are you learning, class? Okay, let me pause for a while. Maybe I hope you're learning, class. I hope you're increasing your skills in Excel, in financial modeling. Yeah, increasing the okay. So just one question again. Did you learn this, class? In your financial management, the one with the negative cash flow, aside from the initial investment, and the one that says that there are two possible IRRs. Okay. Okay, so good, which means that this is new learning for you. Okay. All right. Okay. So let's go here, class. We have two more topics, and then I think we'll be able to finish that. And then for next meeting, we will have what we're going to do is one last model here, and then we go to the new topic. Okay. We'll do portfolio optimization in Excel and other very important topics for financial modeling in Excel. We'll have to discuss when will be our face-to-face exams, and the others will be cases, projects. Okay. So let's have this now, class, crossover. Okay, so you have two projects, Project X, S, and Project L. You have the same initial investment, and these are your cash flows. So the objective is for us to determine the NPV profile for Project S and Project L. Quite similar to this one, class. Quite similar to this one. Okay. So both have an initial investment of 1,000. Okay, and these are their cash flows. Okay. Now let's compute first for the NPV. Okay. NPV, IRR, and MIRR. I'll give you 1 minute, please, to compute for that. I'll pause recording first. Okay. Is my screen sharing now? Class, is my screen sharing? Okay. All right. So I hope you got this, class. NPV, pretty straightforward. Just one formula here. Okay. So it's your, the rate is this one. You can fix the column because I'm going to copy the formula to the right. And then these are the cash flows, C5 to C8 plus the initial investment. Okay. And then I copy this to the right to get 100.4. Okay. So I didn't put two formulas here, just one formula, copy to the right. IRR, same thing, pretty straightforward. IRR, or your cash flows, copy to the right. And MIRR, same thing. Okay, cash flows, and then your finance rate is this one, and then your investment rate is the same. Okay, so you notice that based on NPV, Project L is better. However, in terms of IRR, you can see that Project S seems to have a higher IRR. However, when we got the MIRR, okay, you have MIRR, you have your Project L is better because MIRR will agree, okay, will verify, will agree with NPV. Okay, so here you have a case where your NPV and your IRR gives us different results. And as we know, the choice should be, of course, Project L. But we can learn something from this, class. Let's first compute for the indifference point. What do we mean by indifference point? That is the rate of return where you are indifferent. Okay, you don't care whether you use Project S or Project L. Okay, it doesn't matter if you choose Project S or Project L. At 10%, class, you choose Project L. But what weighted average cost of capital will make you indifferent? Okay, so let's just put here a value, class. Let's make it 0%. We're going to look for this, class, so that the difference will be 0. We're going to use data, okay? And here, class, data, where's that? Here, what if analysis, yeah. And then we're going to use goal seek. But before we use goal seek, let's first set up our model. So let's compute here the NPV of NPV for Project S. The rate is at 10%. Okay, let's fix this. Also the column, comma, we need to copy it to the right. And then our cash flows will be this one, right? And then plus this initial investment. Control Enter. So at 0% weighted average cost of capital, our NPV is 300 for project S. If we copy this to the right, okay, we'll have a higher NPV for project L. And the difference of this is equal to, just get the difference, 300 minus 475. Okay, we can change this, let's make it 1%. And you notice that the difference, okay, became 155. And you can make this 5%. Okay, the difference is going down class. Make it 8%. Okay, 45. So I want us to find the indifference point is that level of return where your difference is zero. At 11%, let's see. But it's already 10 point. So it's coming closer and closer at 12%. Okay. So it's already positive as we exceeded. So maybe we can lessen here at 11.5. Okay. Maybe still increase this one. 11.6. Okay. All right, etc. class. So our target is to make this zero so that whatever this return is, discount rate, that makes this zero is called your indifference point, which means that if that was the weighted average cost of capital, you don't care if you choose project S or project L because their NPVs are the same. Okay. All right, let me pause for a while and again, let me repeat. We're looking for this rate of return, this discount rate, where the NPV of project S and project L are the same, okay? So that their difference is equal to zero. So in that case, if their net present values are equal, then we will be indifferent to choosing between project S and project L. So whether you choose project S or project L, it doesn't matter because your NPVs are the same. Okay, so let me pause for a while. Is that concept clear, class? The indifference point where your NPVs are the same. Okay, good. Thank you. So others, please. Okay. How about the others? I think I'm missing. Yeah, okay, good. All right. Now, how do you find that? Of course, you can do this manually, but it will take us long, okay? You'll keep on tweaking, you'll keep on subtracting or adding to your number until such time that this becomes practically zero. But there's a better way to do this. Okay, so once you have set up your model, okay, you have your discount rate here, you have your NPV here, you have your NPV here, you have your difference here. What we're going to do is to ask Excel to find this point so that this becomes zero. Okay, so that's what we're going to ask Excel. And the way to do that is using what if analysis and then here goal seek. Okay, so please click that class, goal seek. Okay. All right, please chat if you have access goal seek. Let's start doing this together. If you have access goal seek class, okay, good. Okay, I'll wait until everybody is able to get this. Okay, good. Okay, I got only 3. How about the 3 others? Okay. Okay. Waiting for 2 others. Okay. Aliana, Sophia, Sami, and okay. All right. In Mac. Who's using Mac, class? Who's using Mac? In Windows, yes. Yes, Sami, please.
Oh, I'm just using Mac po.
Okay, Sami, where do you get the goal seek?
It's under data,
Under data, okay.
and then it's in what if analysis.
Yeah, same as here, right?
Yes po.
So Jishan, it's data, and then same what if analysis under, I don't know if it's under forecast in Mac, and then click then you have goal seek. Okay. Okay, good. Thank you, Jajan. Okay, thank you, Sam. Okay, so once again, I'm going to go to data and then what if analysis and then goal seek. All right. So notice here that you have here arrows or arrows. But in your case, this might be spreadsheets, icons. No? This might be spreadsheet icons. It only means, class, that this one is linked. This is to be linked. You don't type anything here. On the other hand, this one with no icon here, you have to type the figure. Okay. So how do we run this, class? Set cell. What are we setting? We want to set this difference to be equal to 0 by changing this cell. Okay, so you notice that this can only work if you have already prepared your model. Okay, we want to set this cell, so you should have the difference here to be equal to what value? This should be 0 by changing this cell. Okay, before I control alt print screen, okay, let me type that. In your case, I think it's command option print screen. Okay, I did that so that I can paste this one. Then okay, class, okay. Then there you go. Okay, control V, there. Okay, so I I pasted the goal 6 so that you remember what happened here. So this is from, maybe you put their notes, in your notes, data, and then what if analysis, and then goal 6 for you to remember. Okay, and then I'll put this to the right, there. Okay, so in fact, if I delete this class, delete that. So it starts from 0. And then let's practice again, data. What if analysis, goal seek. Okay, again, set cell, this one. To what value? You have to type. This is not linkable. There's no icon here. And then by changing what cell? This cell. So this one will iterate, try to find that interest rate, which will give us 0 difference. Okay, so you see, very fast, 0. All right, so it's 11.975. So at 11.975, we are indifferent, class. We are indifferent to, let me just decrease, okay, maybe, yeah, let me just increase here. Insert. All right. Okay, so let's now, class, let's now do project S and project L. Okay, once again, we start with, let's say, what was my instructions here? Maybe 0 up to, we have 11.975 here. Maybe 0%. Okay. 0% up to maybe increments of, let's make it 1%. 1%. Okay. Up to maybe 30%. Let's see. Okay, let's put it at 30%. Maybe, yeah, let's see 25%. Yeah. So we're once again going to compute for your NPV. Okay. So this is equal to the NPV of rate is 0%, and I'm going to fix the F4, fix the column because I'm going to copy it to the right, comma. The values are this one. So I'm going to fix the, no, I'm not going to fix the column because I'm going to copy it to the right, and then plus this one. But this one, okay, wait. We have to fix, sorry, the rows. F4, there. And then this one also fix the row. Okay. 1,000. All right, control enter. So the NPV of project S is 300 when the weighted average cost of capital is 0. For this one, NPV is equal to, the rate again is this one. Okay. Actually, sorry, I can copy this. Okay. There. That's the reason why we fixed. Okay. All right. Then don't forget, let's put the point of indifference 11.975. I'm going to include that here. Okay. Another thing also I forgot. Let's also include the IRRs. Okay. IRRs and the MIRRs. Okay. So first is IRR of okay, let me put this one is equal to, this is the point of indifference. Let me put also the IRRs. 14.5. Let's start with this one. 12.1 and 12.7. It should be, let's see. Okay, 12.1. I'm going to, this is 12.1 is equal to 12.1. And also I should have equal to 12.7. I'm inserting class the IRRs, the MIRRs, and maybe I'll put this in red so that I know that these are, let me put here MIRR. This is MIRR of S. This is MIRR of L. Okay. Okay, what else? This one, indifference point. And we also have IRR, 14.5, 13.5. 13.5 first, and 14.5. It's equal to 13.5 here. So this is your IRR of L, and this is equal to 14.5. This is your IRR of S. Okay, so let me put this in red. All right, we have included here in our NPV computation all the relevant rates of return. Okay, so we can copy this now. This is our NPV. Okay, this now can be double click here. There you go. Oops. I'm going to Control Z. Sorry, let me remove the field here. Okay, and then you put here. Okay. All right, let me give you some time to do this, a few minutes. And once you're done, kindly chat, please, in the chat box. Okay, good. So let's wait for your other classmates. All right. How about the others, please? We'll wait for you. Okay, thank you. Well, si Nix, sino pa? Okay, Sophia, thank you. Okay, good. All right, so we now have the table of the NPV class. And if you take a look at our, let me just shorten this a bit. Okay. If you take a look at our values here, this is the indifference point class. And you can see that their NPVs are the same, right? So as I said, the indifference point tells us that if it's at that point where you're you don't it doesn't matter what you choose, project S or project L. Here you can see that modified IRR. Okay, you can see that the S is better. This is the MIRR for S. This is the MIRR for L. Okay, 12.7. Wait, MIRR for L. Okay, what happened here? Let me check. D. Okay. Oh, wait. Sorry. We don't interpret MIRR that way. We interpret IRR. I'm sorry, class. So IRR, okay, that's the internal rate of return where your NPV is equal to 0. So here, at 13.5% for L, you can see that the NPV is 0. At 14.5 for S, you can see that the net present value is 0. Okay, so the best way to determine which project should you choose based on your weighted average is to plot this. So let's highlight this, Control Shift down arrow. Okay, let's highlight that. And then insert your plot here. Okay, let's use this one. All right, so let's take a look at this one, class. Okay, this is called your NPV profile. Okay. NPV net present value profile. Okay. All right, let's see, class. And let's come up with a decision rule about this. Okay, first, class, is you can see here the NPV profile. You can, of course, you can increase this, class, into higher, but it looks as if this will not change anymore. It will continue going down. Okay, now you can see here the indifference point. This is 11.11. This is our 11 point. Okay, let's move this in between. This is our 11.975 here, class. So what can we say about this? Okay. For discount rates less than 11.975, you can see that the red one, what's the red one class? The red one is your project large. Okay. The red one is project large. You can see that your preference will always be the large project. Right, class? You can see this one. The red one will always be higher than the blue one. The net present value of the large project will always be higher than your small project. Okay. And then you can see, class, that this at this point, 11.975, okay, the net present values of each of them is 42.84. The same. That's why they intersect here. So we are indifferent whether to choose project S or project L if the weighted average cost of capital is 11.975. And then after this one, class, for a brief period, you can see that the blue one is higher than your red one, which means that the project S is preferred over project L. And that's only up to, okay, up to what? Up to this point, which is the IRR of project S. And that's IRR of project S is 14.5%. Up to this point, which is 14.5% class, you prefer project S over project L. Okay, so let me repeat. Lower than 11.795975, you'll prefer project L. From 11,975 up to 14.5, you'll prefer project S. In fact, at 14.5, here at 14.5%, project L will already be negative. Okay, negative 24.37. Okay, and then beyond that, beyond 14.5%, okay, you don't have any choice. The net present values are negative. Okay, for project L, if you're only going to choose project L, okay, let's say you're not going to compare it with project S. For project L class, you can only accept that project up to 13.5%. At 13.5%, which is the IRR of project L, your net present value is zero. Lower than 13.5%, higher than 13.5% class, your project L has a negative net present value. Okay. On the other hand, if you're choosing project S, you can choose up to a discount rate of 14.5%, because at 14.5%, the net present value of project S, okay, this blue one is zero. Okay. For project L, beyond 13.5%, no more, because the net present values are already negative. For project S, beyond 14.5%, no more also, reject, because the net present values are negative. So you take a look at this individually and it's a comparison. Once again, project S, okay, the small project, the one in blue, the project is acceptable only up to 14.5% discount rate. Okay, if it's less than 14.5%, the project is a go. It's okay. If the discount rate is higher than 14.5%, reject the project. For project L, the project is okay up to 13.5%, because at 13.5%, the net present value is zero. Okay, lower than 13.5%, the net present values are positive. Greater than 13.5%, project L has negative net present values. Okay, so those, taking a look at it, if they were mutually exclusive projects, okay, if they were independent projects, if they were independent projects, then you take a look at them one at a time. If they're mutually exclusive, then you'll have to choose. So what again is our conclusion? If they're mutually exclusive, if the discount rate, if the cost of capital is below 11.975%, then you choose project L. If it's 11.975%, then you're indifferent. Okay. If it's greater than 11.975%, up to a certain level, up to 14.5%, you choose project S. Okay. Beyond 14.5%, you don't choose any of them. Okay. So that class is your NPV profile. That's how you use between two projects. Okay. Especially given that their NPVs and IRRs are conflicting. If they're not conflicting, class, then you will not have a plot like this. You will always have the better one higher than the inferior one. Okay, let me repeat that. This only happens, class, when you have a conflict between your NPV and your IRR. If you have a project, if you're comparing two projects and then the net present value or the IRR is better for one project, then your plot will not look like that. Okay, it will look like this. Okay, so this is, let's say, project A, and this is project B. Okay, that will be your NPV profile. Okay, at no point will the other project be higher than the other project. So that's if there's no conflict in your NPV and IRR. So maybe you can experiment on that. You can try to see some cash flows and plot. Okay. So it's time already, class. So this one is this one is more for practice. Is it the same? 500, 400. It's the same, sorry. Crossover one, crossover two. Yeah, it's the same. So okay, I'll create, class, a folder for your assignment. Please post there. You have to post it, class. I'll give you up to you should have submitted it. I forgot to put it. I'll give you up to 12 o'clock, class. Please submit in the assignment folder, which I'm going to create now, the plot of your of the interest and principal payments. Okay, are there any questions, class?